Yeah, yeah.
Okay. Hi, everyone. Welcome to the session on deploying machine learning pipelines using PyCaret. Now, surprisingly, we have the creator of PyCaret right here. Our speaker, Moez Ali, is an analytics leader who enables domain experts to solve important business problems. Currently, he is heading the Center of Excellence in Analytics at PwC Canada, delivering high visibility and high value projects. For those unattended, PyCaret is an open source, low code machine learning library in Python. It can be used by professional data scientists as part of their machine learning workflows and to build rapid prototypes quickly and efficiently. Now I'll be transferring the control to the speaker.
Hey everyone, can you hear me okay?
Yeah, we can
Yes,
hear you.
yes, yeah, yeah.
Okay, so let me start by sharing my screen. Please confirm once you see my screen. You see my screen?
Yes, yes, yeah.
Okay, perfect. So start getting into it directly. Okay. Okay, hello, good morning, everybody. Thank you for joining me here today. My name is Moez Ali, and I'll be talking today with you about building end-to-end supervised machine learning pipelines and how to deploy them on various cloud platforms, or how would you actually use machine learning pipelines in real life. And we'll talk a little bit about Azure, AWS, GCP, and the demo I think I've prepared would I would use PyCaret to deploy on AWS, but the process for other cloud services is also pretty similar in PyCaret. And then I plan to show you a couple of demos today, and my talk would be focused mostly around how you can build the pipelines using PyCaret and then use them with the API endpoint on front end or an application like Streamlit or Flask. Okay, so you won't become expert by the end of this talk, but at least it would give you building blocks that you'll be able to connect yourself. Okay, let's get into the presentation. Something about myself: data scientist working in industry 10 years, very diverse career. I have mostly worked on problems and solve problems in healthcare, education, and consulting. Very active open source contributor. April 2020 this year we have open source PyCaret, which was in making for last 12 months. Started as a school project on side and ended up becoming a mainstream software this year. Member of chartered management accountant bodies in UK and Canada as well, and have lived and worked in 4 different continents in last 10 years. So traveled a lot for work and work in different countries and in different roles. Currently based out of in Toronto, Canada. Have been here in last 4 years, but these days keeping strong in lockdown in Toronto. Okay, very active on social media. Primarily, I use LinkedIn, Twitter sometimes, but if you'd like to follow me on social media, here's the link. I used to write very actively on Medium a few months ago, not anymore, but still there are quite a few articles that you can get if you follow me on Medium. All right. So agenda for today, we are very tight on time. We'll first, so I'll assume that if you are here, you don't know a lot about PyCaret, or you're here to learn more about using PyCaret, how you can use it as a software, as a tool in your day-to-day life, right? So we'll talk about what is PyCaret, and I'll obviously give you hands-on knowledge of how to use PyCaret. I'll code in front of you. I'll show you, introduce the problem statement to you. I'll show you how I approach the problem. I prefer to do live coding so that you can see how I am approaching the problem. Okay, and then we'll do a first demo where we'll build machine learning pipeline together. It's a classification demo, supervised machine learning. Another demo will do it using regression, although with PyCaret, it is not different whether you do classification or regression. It's the exact same thing. The only thing different would be the business problem or the context itself, obviously, because in classification, you are predicting a binary outcome. If you're doing binary classification and regression, you're predicting continuous value. The use of technology or use of software is same, but the business context would change a little bit. And then we'll try to see a front-end demo of Streamlit. I'll show you the application that you can build very quickly in such a short amount of or such only few lines of code in Streamlit. It's again It's new. It's a new framework, but growing. It's very friendly. It's very Pythonic. Okay, I'm not gonna code Streamlit in front of you. I'll have a sample code for you, but I'll show you what the code chunk is doing. And I think it's if you are in Python, it's very intuitive. And then we'll talk about Flask. I mean, it's a pretty similar thing. You have your machine learning pipeline. The new data comes in, and then you have some kind of endpoint where you pass on your trained model or trained pipeline, and the new data through API, it kind of generates the inference or prediction on new data set. Okay. Some important links, very important links. If there is so much I can tell you in this 1 hour about PyCaret and the deployment, right? It's a big subject. Perhaps the entire bootcamp is not enough too, but all these links would be very helpful to you. If you in future decide to pursue this or use this or somehow integrate it with your local packages in your company where you're working, you would need these links, right? The first one is website, pycaret.org. Has a lot of documentation, history, blah, 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 right? So very useful website. API documentation, read the docs. This is a automated documentation. So anything we change gets automatically updated here. So the best place to go and read about API documentation is definitely going to this link instead of reaching out to PyCaret members or myself on LinkedIn or Twitter. You know, our responses could be slow. So your best place to go to is website documentation. And if you have questions, please post them on GitHub. Please post them on GitHub. As much as I'm happy to help you on LinkedIn, it's not helping everybody else, right? If you have questions, chances are other people have similar questions, and we want you to post them questions on GitHub so that tomorrow or 1 month later or 3 months later, if other people are having similar problem, they have the answer, right? So replying personally on LinkedIn is not very efficient. But apart from that, if you ever want to reach out to me on LinkedIn, stop by and say hi, feel free to do that. My LinkedIn profile is here. This is the LinkedIn profile of the company or the library. We have a YouTube channel, Medium. The most important link here is this yellow highlighted, github.com/pycaret-demo-dphi, because anything that we're going to do today, we're going to talk about the presentation, including itself, everything is uploaded on this link on GitHub. So this presentation that you are seeing on screen is already on GitHub. Okay. There is a lot of resources about PyCaret. Like people have written, and we are extremely thankful to community who has came forward, supported us by writing excellent content in last 6 months. So if you Google it, you would find a lot of videos, a lot of posts, a lot of towards data science articles. And I have just attached some of the official ones that I have written in last 4 or 5 months, right? And if they are mostly 8, 10, 12 minutes read, they're very simple. If you haven't done Python ever in your life before, you will still be able to follow them and deploy. Okay, they're that simple. Most of my articles start from teaching you how to install Python. All right. Again, I'm not going to go through these, but point being, the presentation here is on GitHub, and this is kind of a compilation. And obviously, this is very old. Okay, this misses. I mean, this is updated 2 or 3 months ago, so it doesn't have all the articles that was written in 2 or 3 months in last 2 or 3 months. So I'm assuming you would know your way to Google, right? You'll just Google it and find it. Okay, so let's get it started. So this is the diagram. I'm sure if you're here today, I'm very certain that this is something you have seen before. There's nothing new. This is a ML lifecycle at a very high level. You start with a problem statement. In the second phase, you gather your data, you perform ETL jobs, whether you're using Spark, MapReduce, Hadoop, Hive, whatever. Doesn't matter, right? Point is ETL, right? You take your raw data, you transform it, or you prepare it for machine learning. You also do data analysis, visualization, sometimes also called as EDA, right? So this is the standard process. Problem statement, you gather the data, you set up ETL jobs. ETL jobs means that you have processes that would reach out into your raw data table, SQL, Oracle, whatever database you're using. They would extract the data, transform the data, right? Because data is in the tables or in the infrastructure, they're not structured or stored in a way that is readily usable for machine learning or anything, as a matter of fact, right? So extracting 10 different sources of data, and sometimes it could be 10 different sources as well, right? So extracting that, combine that using joins, blah, 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 right? Doing that is all transformation. Normalizing them, that's transformation. That normalization, not min-max normalization, okay? That you do, and that's the, I don't know, some people generalize that this is 80% of your work, this is 90% of your work, this is 40% of your work. I think, this is wrong. I mean, it depends on the problem, right? Sometimes you're working on projects where really machine learning actually means one simple generalized linear model, right? Sometimes that is your exact requirement, okay? And sometimes there are industries where by law you're required to use explainable models. So there are industries that are bound to use linear models, okay? They cannot use XGBoost, no matter how better XGBoost is. They cannot use RNNs, they cannot use state-of-the-art models, okay? So sometimes in a project, that is all they're about for machine learning, just a linear model. And 99% of the job is compiling the data, extracting the data, or doing the research work, or doing the visualization. So it is very, I would say it would be very naive to generalize that 80% of the work is ETL. That's not true. That depends on problem. Okay, anyways, going back to the topic, these are the 4 standard steps. Problem statement, gathering data, ETL, and then visualization, sometimes also called as EDA. Doesn't matter, you use Plotly, ggplot, Power BI, Tableau, Google Studio, or even you use SAS, it doesn't matter. Platform doesn't matter. That's just a generic idea. Then the last 3 steps, which is training machine learning model. And by training, I mean if you're using scikit-learn, .fit. If you're doing neural network, by training, I would mean .add, when you add layers, .fit, .compile, .fit. That's the training process. At the end of the day, you are not doing anything there, right? It's a process. You're just running a standard code and training your models. The idea is, or the value is, what model to train, right? So you bring a lot of knowledge. Being a data scientist, I assume you bring a lot of knowledge to shortlist or remove the noise out of the process. And instead of running 50,000 different models, you would be able to shortlist. Okay, we'll iterate through this 7 models, and we'll see which model is best in terms of performance versus the time taking, right? Because in a school environment, in an academic environment, one thing is ignored: cost is ignored. In real life, cost is the most important factor. I like you. If you come to me and say, I can improve the accuracy by 1%, I say, oh man, that's great. I like it. But at what cost? Do you need 15 hours to do that? Do you need 15 hours of production and 3 months of experimentation, or what, right? At the end of the day, it is a cost benefit analysis. You can improve my model by 2%, but you need 2 years for that. I will see, okay, the problem is customer churn. I don't care. The problem is detecting cancer, curing cancer. I care about 2%, okay? So always think in that context. Okay, so here the training, hyperparameter tuning, and deploying models. We are gonna focus our talk in these 3 areas, and that's basically the areas where PyCaret would help you as well, okay? So I'm gonna zoom into this 3 particular boxes. I will show you the granular life cycle. Okay, so this is how granular life cycle looks like. You start with a business problem, you define your machine learning objective, you start collecting data, you analyze EDA, but then a standard process starts. You split your data into train and test. You handle data types differently. For categorical variables, you have a bunch of options in terms of encodings and what do you call it? One-hot encoding, this encoding, that encoding, right? Different methods doing the same thing. Because you cannot work directly with categorical data, there are n number of ways to convert categorical data into numeric data so your machine learning models can consume. Which one is better? Nobody knows that. There is no single answer, okay? Depends on the business context, depends on the data. Different methods work different times, okay? But the point is converting categorical variable by some technique into numerical variable, one-hot encoding being the simplest one. Target encoding is another example I could think of my mind. Sorry about this. But you have to handle different data sets differently. Different data types differently, right? So for example, if you have a missing value in categorical data, your imputation method to impute the missing value is different than numeric, because there is no such thing as mean of categorical data, right? But in numeric, your easiest way is you take a mean. I'm not saying it's the right way or wrong. It depends. Okay, so the best thing in machine learning, it depends. Nobody can give you the solid answer. And if somebody is giving you a solid answer, that one-hot encoding in every circumstances is preferred over X, that's probably a wrong answer. I'm sorry to say that. Okay. Okay, then you impute missing values. You apply different kind of encodings, scaling. There are n number of methods: min, max, z-score, quantile, blah, blah, blah. Which one is the best? Depends what type of data you have, what type of problem you're solving. Remember, behind the scene, there is a lot of statistics involved, right? And the models that are as easy for us to call dot fit and dot predict, when they were created, there is a maths involved. Maths had some assumptions, and normally, unfortunately, people ignore those assumptions, but that's why there is no better answer, right? There are literally some models that are created for a very specific problem. You would use it on your data set, on any data set, it would work. It would not perform well, but it would work. But the answer being, are those models worse than anything else? Well, no. The problems those models or algorithms were created for, or the type of data that those algorithms were created for, they would outperform anything else in that environment, right? That's why there is no right answer, which one is best. And if you ever find yourself picking or deciding on favorite algorithms, know that probably you are doing it wrong. There's no such thing as top 10 algorithms or top 5 algorithms or favorite algorithms. No such thing. Feature engineering, you do a lot of feature engineering, you do a lot of feature interaction, you do feature selection. There are n number of methods. There's wrapper-based method, there's this method, that method, there's thousands of techniques. Then you start model training, right? And the question is, how do you set up your cross-validation environment? Then it comes to a matter of, okay, choosing the cross-validation strategy, and there are 1,000 different techniques. K-fold, stratified K-fold, group K-fold, this fold, that fold, 1,000 different techniques. Which one is best? No answer. Depends on your data, depends on the problem. No best answer, okay? But the point being, there are different techniques. Okay, and the reason you are doing all this so that you track performance. Imagine in this entire process, you have generated, I don't know how many zillion data points, okay? Metadata points. You've generated so many metadata points in terms of hyperparameters, in terms of parameters, in terms of settings, in terms of blah, blah, blah. Okay, the goal is you track performance. You keep repeating this process, you track performance. Then you tune your model, you track performance, you ensemble it. Sometimes you do bagging, sometimes you do boosting, sometimes you just combine them using some kind of weighted method. Sometimes you are in a situation where you have to invent your own novel methods to combine models, okay? It's not, I mean, in real life, things would go beyond bagging and boosting. You have to sometimes work and get a very solid grip on statistics and devise or design your own novel methods, which are proprietary, which are very specific to the problem you're solving in the context, right? So sometimes you have to do that. But the goal is you are doing that so that at the end of the day, you can get a model and a supported pipeline that performs well on new data, right? Same problem. You sometimes would rely on blending models, stacking models, again, same ensembling techniques, but you are tracking performance, you're analyzing, doing diagnostic plots, error plots, confusion matrix, AUC, you're doing all those things. And you are generating zillions of data points in terms of metadata, right? Imagine if you are iterating this process even 20 times, I can tell you have generated more than 18,000 data points. This is our estimation. You have generated more than 18,000 data points, including hyperparameters of model, parameters of training, what else? The parameters of entire pipeline, right? And the problem is you do it on repeat basis. You have to iterate it, right? That's the reason it is called experiment. You have to iterate it n number of times to actually come to a point where you select not just a model, but a pipeline. And what I mean by that is this. New data comes in. If there is a missing value, it gets imputed through a KNN imputer. Next step, all the filled values, assuming no missing values, it passes through a transformer, which converts the raw value into z-scores. This is your standard scaler from sklearn, if you know what I mean. Next step, once the standard scaling is done, we extract the features out of it, because when we were doing our experimentation, we realized that the raw features doesn't have as much value as if I were to take feature A square and the polynomial of feature B and interact them together. Why it work? Well, that's your job. If something like that in an iteration comes out, jumps out, that's where you invest your time, okay? That's why generalizing that 80% ETL is a bad idea, because you never know what are you getting into, okay? So if during an experimentation, during an iteration, if something jumps out like this, that raw feature has zero importance, two raw features, let's say A and B, zero importance, but when you interact them, it is the highest important factor in your model when you're checking feature importance or coefficient weights or whatever method you're using. Okay, if something like that comes out, that's your primary job to investigate there. Okay, that's the hidden insight. Everything else is okay, you're doing, it's part of your job, but that's the main thing. Okay, and at the end, you deploy model. You iterate over 1,000 different models or 5 different models, depending on the problem you are solving, because again, this is the same thing. There is no right answer. If you ask me how many times I should iterate, there is no right answer. Okay, I'm worried if the recording is working. Everything is okay? Yeah, seems like okay.
Yeah, it's working. It's working. It's
okay, very good.
Yeah.
Very, very good. Okay. Again, how many times should I iterate this process? 5 times, 10 times, 20 times? I don't know. There is no right answer. Okay. Sometimes you're solving a problem which is worth spending years and years, right? Imagine you're trying to figure out you've joined SpaceX working with Elon Musk and sending a rocket on moon, and you are responsible to build a model that would predict, looking at the satellite images, it would predict where the rocket would land. Okay. You're solving something like this versus you're solving a problem for a small size company of customer churn. I think it is very natural. It's very intuitive. You know yourself which problem is worth doing more iterations. Okay. All right. By the way, I just read this morning with Elon Musk, one of the quotation from Elon Musk, which said that your salary or your pay or whatever you make in a job is directly proportional to the difficulty of problem you are solving. So pretty similar context. So manage your time accordingly. Okay. Cutting through the theory, let's talk about what is PyCaret. I'm not going to invest a lot of time in theory of PyCaret. I just want to show you directly hands-on in the notebook. I want to code in front of you. That would give you a better idea and put you in a better position to understand. But in bottom line, PyCaret is an open source low-code machine learning library. Initially, when the first version came out in March 2020, it was a very simple library. Over the time, it has grown into something internally we call model management, and the reason we did that so that we can push PyCaret commercial adoption and research adoption, and you will see in a while why I'm saying that. So now PyCaret is a low-code machine learning library. It's a software. It's an end-to-end model management tool that can automate your machine learning workflows. So people would confuse it with the AutoML, and I'll tell you, it's not like any other AutoML. It's a software that automates your workflows, which means using PyCaret you can create your own customized or proprietary AutoML. Although I don't think so if there is a value in doing that, but you can customize your AutoMLs, right? It's not a standard AutoML. You're not limited to a workflow that we have designed for you. This tool is there to build workflows, okay? And you drive it. So it's not, I mean, obviously there is a way you can go driverless in PyCaret, but the original intention is you are sitting in front of computer. You want to code it yourself. For one, either you don't have a luxury in your company to have license for Data Robot or H2O, or because they are paid tools, right? And the licenses are expensive. That is one thing. Two, you are not permitted to use cloud. There are, I don't know, more than 80% industries in Canada restricted by some kind of law, right? Major big banks, you would think that they must be doing something cool, but they're not even allowed to use cloud. So you don't have access to Azure, AWS, GCP cloud services, automated ML services. Three, and the most important reason I think you would want to do modeling in front of your computer, because you like doing that. You don't agree with the idea you upload a file and come back 3 hours later with a model. Maybe that's the reason. I don't know. But if you ever choose to be doing in-person modeling, then PyCaret just sits on top of many other libraries. So instead of you interfacing directly with scikit-learn, XGBoost, GetBoost, you just interface with PyCaret if you wish to. 3 things I tell about PyCaret. It's easy to use. This is our value proposition. If this was a business, this would be my value proposition, that there is no other tool which is as easy as PyCaret. And you literally don't need any Python background to use PyCaret, like literally. It's a productivity tool. It's a business ready solution. PyCaret can help you with preparation, data preparation, pre-processing, model training, hyperparameter tuning, analysis, interpretations, blah, blah, blah. And then eventually our goal, remember, our goal is to finalize one best model that we can deploy in production. And as you do all this, you generate a lot of metadata, you generate a lot of things that you want to log, okay? So experiment logging is one big thing of PyCaret. As of now, there are 6 modules in PyCaret. Modules, think it as building blocks, okay? And 6 modules, each module for a use case. So for example, there is a classification module which supports the classification use case, whether binary, multi-class, right? There's a regression use case which support regression. There's a clustering, which is unsupervised clustering, unsupervised anomaly detection, natural language processing, association rule mining. NLP, we only have so far, at this time, we have topic models and some basic stuff, but nothing state of the art. We realize NLP has taken a huge leap in 2020, and there are many such libraries that are at the front of that progress, and we don't want to duplicate the effort. So to be honest, in past 2, 3, 4 months, our focus was never on NLP because there are literally libraries which are specifically for NLP. So, and we don't want to duplicate efforts in open source community, but we haven't decided anything concrete in terms of what would be the future of NLP module in PyCaret. But at the moment, I would say if you're doing it for the first time, I think PyCaret should be a go-to place for NLP. But if you are intermediate level user, don't expect much in terms of NLP from PyCaret. You're better off using Hugging Face, BERTs, and all that cool stuff yourself directly. Our roadmap is pretty strong, pretty strong. We have integrations planned with Dask to allow scalability on multi CPU. So you can parallelize your workloads on a cluster, okay? We have integrations planned with TensorFlow, PyTorch, probably one of them, and it hasn't decided yet. Integration with Fast API, it's a very small ticket item. Support for multi-label classification, so basically when you're predicting 2 Ys or 3 Ys instead of 1 Y, right? It's different than multi-class. Multi-class, still 1 Y, you have 7 categories, you have to predict 1 out of 7. Exclusive, not exclusive, but multi-label is different. Custom pipeline tuning and transfer learning. NLP, this presentation, I told you, it's two months old. So in last 2 months, we had a couple of meetings, governance meetings, where we have taken a hard look again at whether we should continue with NLP or not. But we'll see. No answer now. Okay, we are up for demo now. Very good. So we have spent 30 minutes. So we have good time to spend in that. Very good. So what I'm gonna do is show you a couple of things. So one is website, right? The other one is documentation. Website. This is website. Very simple, very intuitive. It's different than how like it's better, right? It's you can read it in English, you can understand it, right? It's a very toned down level in terms of difficulty. It's very intuitive in the sense that if you want to check, let's say, what does normalization do? You come here, pre-processing, select one category, click on that. It would tell you, it would explain you. So you can use this as a learning resource as well, right? What is normalization? It would explain you, right? Parameters of normalization, how you can use it. So the code sample here, and then before, this was the data set. After, this is what happened when you normalize. So very intuitive. Try this next, transformation. Same thing. What is transformation? What are the different methods you can try? How to use it before, after. I think that's really good, right? Very simple. And then there are a lot of tutorials, right? So let me show this. Now this is our API documentation website. Read the docs. PyCaret installation. By the way, I missed to mention one big point, which we did in last release. So now you can use PyCaret with CPU as well as with GPU. So no change in terms of your coding. You just pass one parameter in setup that kind of tells PyCaret, instead of using CPU from your laptop, use GPU. And if we don't detect GPU, we'll tell you, man, you're joking. You don't have GPU. Why you want to use GPU? How can you use GPU? Okay. So no change in code, but you just flag use GPU true, it would use GPU. And I'm not going to focus or tell you about the benefits of using GPU, but there are benchmarks out there. We have published the benchmarks. In some cases, it's 80 times more efficient. In some cases, it is 1.3 times more efficient, right? Depends on the algorithm, depends on the data, depends on the dimensionality, so many things. Okay, so installation, very simple. Then you have tutorials. All the tutorials are updated, by the way, after a very long time. We took some time to update documentation. So now with the latest version, all the tutorials will work. So this is the beginner level tutorial that I've opened in front of you. Binary classification, it would explain you every single thing, every single step, right? Very intuitive. If you are doing this thing for the first time, it cannot get simpler than this. This should be your notebook that you begin with. It's simple, period. Okay, all the modules, and then the module documentation. And you would find yourself spending a lot of time here if you're using PyCaret. Where you click on documentation, remember 6 modules here, and they are here by, so it's like a Docker strings. Okay, these are Docker strings. So you would spend quite a lot of time here if you ever get stuck in something. Okay. There is a YouTube channel, there's a LinkedIn channel, Medium. I'm not going to show them. I mean, if you want it, you know how to find it. I'm going to go into this folder. So this folder is basically the files that I've already uploaded on github.pycaret/pycaret DPhi. That's the link. And if you need it, this is the time you copy this link. Okay, let me pause there for 15 seconds. This is the link. This is where you get the presentation. This is where you get the notebooks. This is where you get everything that we are going to talk about today. 5, 4, 3, 2, 1. Okay, go. Okay, this is the repository. Okay, and just so you believe me, where is PPT? Here. Oh, here's the PPT. Okay, very good. I would assume you know your way how to clone the repository or download the files from repository. I'm assuming you already know that. Okay, let me go new and a fresh notebook. And let me zoom in. And let me call this PyCaret Demo 1. If you don't do this, force yourself doing this, because you don't want to be in a situation where you have a folder with untitled up until 123 up until 99. Okay, if you don't force yourself into habit of naming notebook, you would never name a notebook. I have learned this very hard way. So just a tip for you, if you're starting off, the first thing you should do is name your notebook. Okay, and now let's get going. Okay, you can see my notebook. So it's a Jupyter notebook, right? You write code and you get an output. First thing, let me show you. From PyCaret.utils import version. I'm using 2.2.2, right? And if you go to PyPI, this is our last release. So you can see November 25th, we have released 2.2.2. So our major release was 2.2. And after that, these two are bug fixes and minor items. 2.2.3 is going to be out in next 2, 3, 4 days. There are a couple of bugs, and our dependent libraries are changing a few things, so we have to account for that change. But this is a stable release, and we are actively building to, right? So if you ever get to a point where you want to use all the cool and new features that we are building, then there is a separate library called PyCaret 90, right? And if you see, it is automatically being pushed. I don't know, it's supposed to update itself every night, but if there are no changes, it doesn't get updated. So you can see at some point here, November 16, 17, 21, 22. So very frequent. The point being, this library, PyCaret-Nightly, would have features that are untested and they're not production ready yet. But if you want to use it, I suggest you create a separate Conda environment so you don't conflict with PyCaret library, and use it at your own risk. Okay, 2.2.2. And this is the version I'm using because this is the latest stable version. And in PyCaret, there is a module called get datasets. There's a module called datasets. And in datasets, basically, instead of when you install library normally, so imagine even with sklearn, you have something like sklearn.load dataset, right? Something like this, right? So similar concept. The difference is instead of downloading or packaging all the datasets in your computer, what we have done is we have created a repository on GitHub, and when you call get data, it basically goes to internet and download the dataset, right? Just to keep it light. But obviously, I'm using this so it's convenient. But you would be loading data, assuming PDV, CSV, or through SQL. If you're getting directly from SQL, you'd be using some kind of driver, PyODBC probably. But the point being, it doesn't matter how you get the data in. It doesn't matter. I'm just using this because it's convenient. And if you want to see what kind of data sets are available, if you want to play, just call the index, get data index, and you would get this huge table. So you can see 55 data sets. And if you have a good data set that you would like to donate or would like to, make sure to put it in PyCaret library or propose it, feel free to send a pull request and also update this index file. So that's here. So you can see all the data sets, data types, what kind of task we are doing, anomaly detection, association rule, a lot of classification, clustering, regression data sets, target variable name, instances, attributes, missing value. Okay. The data set that I'm going to use now to show you around is this one. Choose. Okay. And let me quickly show you 1,000 rows, 19 columns. PyCaret would generally, as long as your data can fit into memory, right? Million, 2 million, 5 million, 10 million, it will work smooth. The reason I'm not using that data set is I don't have a lot of time waiting here today as the model are training. But here's this, man. If you can use scikit-learn on your data set in past, if you can use XGBoost, get boost, and it was working, right? PyCaret would work. Nothing is being changed in terms of speed or size of model, right? We haven't improved it. We haven't not improved it or made it worse, right? As simple as that. But if you come ask me a question, I have 275 billion records. What should I do? Well, in past, I'm assuming you cannot use scikit-learn on 275 billion. You cannot fit in memory, right? So you are using Spark already, or you're using some kind of parallel processing system, right? That overrides the memory limitation of data set. So that's a simple answer. If you can do modeling on your computer, if you have a size of data set that you can do modeling on your computer, use PyCaret. Because if you can use scikit-learn, you can use XGBoost, get boost, like GPM. If you can use those things on your in-memory computer, PyCaret is same, right? Simple, period. There's no discussion about that. But if we are dealing with 100 billion raws, I don't think so. You ever did that modeling in Python ever, right? With 100 billion raws in memory, it's not possible. Or if it is, please reach out to me. I would love to learn how it is. Okay, so this data set, 1,000 rows, 19 columns. It's a simple classic binary classification problem. Each row is a transaction, and we have to, based on this transaction variables, like the price and this index of store, week of purchase, blah, blah, blah. Based on this, we have to decide whether the customer would buy a CH juice or juice, right? And if I show you the distribution, how do I see that? Okay, so data purchase value counts. So you can see it's a 653 bought CH, 417 bought I wouldn't call it imbalance. Okay, this is okay. You never get 50-50%. Okay, but this is very good. So no problem there. And let's see if we have any in NA. Okay, so no missing value, but I'll show you later. Even if there was a missing value, it wouldn't be a problem. Okay, so the first thing in PyCaret that you need to know is you have to initialize the setup. So the first thing is, because this is a classification problem, I'm going to import things from classification. Okay, and I'm using this star, and some of you might disagree with this philosophy of importing everything. This is not the talk for that discussion, but I have a couple of videos that talks about it. this is okay. As long as you're a notebook environment, as long as you're doing experimentation, this is okay. In production, if you're importing something with star, then that's a problem, because then you cannot trace back. But when you're working with your notebook, I would say there are people who would have strong advices against these things, and know that there are promoters promoting best practices without understanding. But the point being, our examples, our tutorials are this way. If you want to use it, that's great. If not, feel free to call individual things, right? And in 5 minutes, you will see why this is extremely inefficient. But if you want to make an individual imports, feel free to do that. Okay, so if you are, depending on the type of use case, what you're doing, just import from that module. So if you're using classification, which in this case we're using classification, you import it from classification. If you are doing regression, you would import regression. If you're using clustering, you would do clustering. If you're doing anomaly, you would do anomaly, NLP, right? But in our case, it's classification. The first thing you do is call a setup, and in any module. And setup takes two things. It takes name of data frame, which is this, right? It takes a data frame, not the name of data frame, the data frame, which is data is equal to data, and then target, in this case, the column purchase. It takes only these two things. As soon as you run it, it would basically infer the data types using some kind of algorithm behind the scene, and it would return you a table like this. So all your columns are listed here, and the data type we think these columns are. So in this case, you can see we have detected ID column, which is very good. ID is ID. And what we do with ID column is we hide it, right? Because you don't want to use your ID column. So this basically saves you a stop of dropping that data.drop. So it's a one-line code, but it saves you that step. Then numeric, categorical, and then purchases label. How did you know purchases label? Well, you told it yourself, right? So there is no artificial intelligence there, but you have told it yourself. And then this box here. And if you read this line, following data types have been inferred. If they are correct, press enter to continue or type quit. Otherwise, if one of this is wrong, let's say price was a categorical column and it got detected as numeric, you can type quit. And there is a way you can overwrite the data types, and you can read in the documentation. At this point, I'm just going to press enter and say everything is okay. The moment you do that, what it does is it gives you this nice table, right? And this is like a setup configuration of the variables and everything. And let's try to read it. Session ID 5443. This is a random number. So if you're using scikit-learn, it is random underscore state. The problem is when you are doing manually everything yourself, you have to take care of that number in each and every single function that you use. Train test to split also takes random state. Stratified k-fold also takes random state. Random forest also needs a random state, right? So there are so many randomization processes you use. And if you were to do manually, you would just do it manually everywhere, right? This one makes sure that you use, so this one, session ID, this one makes sure that there is one number that is being passed everywhere, and you can use that for reproducing, right? So the good idea, if you want to make your experiments reproducible, instead of passing this line only, what I do, I pass my session ID is equal to 1, 2, 3. And now if I run this is the same grid, but you can see instead of that 5443, it is 1, 2, 2, 1, 2, 3. Whatever the number I pass. If you don't pass anything like this, it would generate a random value and distribute it. 6940. See, this is different this time. I run it again. It would be different number again, 7186. But what I like to do is control my experiment. So I pass a number. Then target column, name of target column, purchase, target type is binary. So if there were more than 2 targets, it would say multi. Label encoding, so CH becomes 0, MM becomes 1. So remember, if you are doing it from scikit-learn, what would you do? You can't use this, right? You have to pass a label encoder, wrap it through something, convert it. Use a map function, convert CH to 0, MM to 1 manually, or use some kind of label encoding from sklearn or anything, right? But you have to do it. Point being, you cannot pass CH, MM, positive, negative, plus, minus as a target. You have to convert it into number. Original data shape. So this is same thing as we have seen through dot shape, 1017, 19, this one, okay? Then missing values, false. We have seen that there's no missing values. Numeric features, categorical features, ordinal features, high cardinality, transform, train set, test set. So see this 11, 12. You had passed one data set, and it has basically done that initial train test split for you using 70-30. If you just look at this number, 748, 330, 322, this is 70% of this, right? So basically 748 divided by 1070. 70%, right? Well, I even don't know why I opened calculator. I have to put a notebook in front of me. I could have divided there, but that's the point. 70%, 30%, but you can change this. And I'll show you there are a lot of parameters to control if you want. Shuffle train test. Do you want to shuffle your data set during train test or not? Well, it depends, right? If you have a time series data, you don't want to shuffle. If you want to maintain the sequence or preserve the sequence, you don't want to shuffle. So again, you have flexibility to control that. What's the downside? Why is it true, right? Because if you want to stratify your splits, you have to have that true. You cannot stratify. With shuffle false, okay? Or maybe opposite, but one way or either you have to have that true. Fold generator, what are you using? K-fold, leave one out, group K-fold, stratified K-fold, and I don't know there are how many number of versions of K-fold. And every now and then you will find one article and somebody promises that this method is going to take over the world. This is over everything else, which is not true mostly. Fold number, how many folds? 5-fold, 10-fold. 10-fold kind of become a customary in the field. It became a standard for some reason. I've never found an answer why we normally call it 10-fold, right? But again, the default parameter in PyCaret is also 10-fold, but you feel free to change it to 5-fold or 3-fold or 2-fold or whatever you want. CPU jobs -1 means it would use all the cores in your computer. Okay, be mindful if you have a super computer with 60 physical cores. I don't know these days somebody would have that, but if you have that, then know that there is a very lower level issue in a Loki library that when your computer has more than 30 logical cores, then it would create problem. In that case, if you are one of those which has 60 cores on your computer, I'm sure you're more than expert to understand the error. But if you happen to be having a hardware with more than 30 processors, just lock, instead of -1, just say 30. Okay. Use GPU false. See, remember we talk about GPU by default it's false, but if you want to make it true, just say use GPU is equal to true. And now see this. Okay, I'm not gonna do that. The laptop I'm using doesn't have GPU or doesn't have a good enough GPU to show, or compatible GPU, I would say. And by the way, a quick note on GPU, we are using CUDA-ML Rapids AI project. So obviously the GPU must be CUDA enabled, which I believe if you have bought a GPU in last 2 years, it is CUDA enabled, and there are certain categories, right? And if you're interested, Rapids AI is the project that we have used behind the scenes. So I'm sure they have somewhere here showing what type of GPUs would work or what type of GPUs would not work, I would say. Okay, and then there are other so many details, right? So fold generator, imputation type, iterative imputation type, numeric imputation, categorical imputation, unknown categorical handling, normalize, transformation, PCA, ignoring low variance, combining rel levels, binning the numeric variables, removing the outliers, setting the thresholds, removing multicollinearity, anything. Okay, so I would not say anything, but 70-80% of the things that you would normally use in machine learning. And to be honest, like most of this, like creating polynomial features and stuff like that, if you're solving real life problems, you'd probably not use it unless something is really specific, right? Because I mean, imagine your polynomial interacted feature happened to be the best feature, right? How would you explain it to your boss, right? Imagine age and marital status interaction ended up becoming the most important feature, and not just by themselves, but by the polynomial of them, right? So something like this: the polynomial of age multiplied by the square root of trigonometry of marital status. If that is the most important feature, how are you going to even explain that to your boss, right? So in real life, you would want to use raw variables as much as you want, as much as you can. With the scaling, it is okay because it's still, you can still interpret, right? But with this polynomial trigonometry and stuff like that, sounds good, very appealing in academic research environment, but in real life, most of these things are kind of pointless, right? but they are there if you want to use. Okay, setup is the first step. Once you do setup successfully, and one thing I want to just point out at this stage, note this, log experiment, false, experiment name, default name, right? Because I haven't set experiment is equal to true. I want to do that because I want to show you that is really, really powerful. Log experiment true, experiment name is equal to, let's say, juice 22. I have no logic. I don't know why I named it juice 22. Small warning, failed to connect to Git. The laptop I'm using for this presentation, I don't have Git here. So, and there's a very good reason I don't keep Git here. But this is just a warning. If you run it again, it would go away. And I'm going to pass this magic command here in Notebook, MLFlow UI, or maybe I'll show you the right way to do it first. The right way is you, not the right or wrong way, but the better way would be you go to the command prompt, you navigate where this file is sitting. So remember, this file is sitting here. If I do dir for directory listing, so this is our file, PyCaret demo1, right? If you type MLFlow UI here, MLFlow UI is for user interface. MLFlow is the name of library that we are using behind the scene to do tracking. If you type it and enter, it should say something here that we are initializing a server. Similar to Flask, in the background, it would initialize a server for you. And then host 5000 is the port on which this runs. It would open this user interface. Okay, this is a very simple user interface from MLFlow, but it is really, really powerful. Okay, keep the command prompt open. I think juice 22. You see your experiment here, and this is what you see. This is the first run that you see. Oops, give me a second. I think my battery, and I don't know why. Okay, you know what? I'll be back in 10 seconds to fix my battery. Okay, I'm back. Sorry, man. Okay. Where were we? Here. Okay, so juice 22, let me explain you the interface. This is running on your local computer. It's a web server behind the scene. Every time we do something, it would create a run. So in this case, you can see we have created a run, start time, end time, and I have hide a couple of columns. So, but it will automatically keep track of user, source, version, so all that thing, right? I'm not gonna go into detail. And when you click on run, it would save all the configurations. So date, duration, how much time it took, and that everything that we control through setup, they're all logged in here. They're all logged in here, every single thing. Imagine, otherwise you would be taking or copying things from here on Excel, right? Or maybe not just drag them at all, which is bad, right? Some unique identifiers, and as you study PyCaret more, you would understand why these numbers would be useful and which cases you can use them, and actually the entire pickle pipeline, right? So it's not just the information, or it's not just the talking, but the actual pipeline as well. So if you, this location here, if you go here on your computer, you see this is a pickle file. This pickle file can be loaded back using joblib, and this is basically the transformers, list of transformers automatically orchestrated for you. Very good, depending on what methods you select here, right? So imagine if you want to normalize things, right? So if you check the docket string of this, you would find this long docket string, and this docket string is same as if you were to go here on the documentation API or go to classification and read this. This is same, okay? Or the other way is you just say help of setup. And it was, again, it's the same thing. I find website more convenient, right? I mean, it's more formatted. It's easy on my eyes to read through website, but it's essentially the same thing. Feel free to use it in any way you want. So let's say I want to normalize my data, right? I want to do min-max scaling on my data. So there's a parameter here, normalize, and read this. When set to true, it transforms the numeric value by scaling them to a given range. Type of scaling is defined by normalize method parameter. Very simple, very intuitive. So what this means is, if I want to normalize something, I'd come here, normalize is equal to true. Missed a comma there. And now if you see my setup grid, you see normalize here. Okay, that's the point. So there are so many, all these things that you see here, you can change them, you can play with them. And in the interest of time, I'm just going to move forward and continue. But now if I go back to my MLflow, I want to show you something. We now have, instead of just one line, we have 3 lines, because remember, we have ran this code 3 times now. One with normalize, so without, this is the first one, without normalize, then with normalize, and then I ran it again without normalize this time here. So if I go into this run, I should see, and if I search for normalize, see the normalize is true, okay? Because I added that code here, right? So this is connected, live, real time. Good. Okay, so since we have talked about setup, the other thing now that you have set it up in terms of experiment, you want to start training your models, right? And evaluate them. So the first thing you want to see is models. This command here, models. When you type this, you see this table, very simple table that tells you these are the models in classification module available to you to use. Okay, very simple. Now imagine if you would have just imported a star instead of star. If you have imported setup here, this code would not work. You have to do this. You have to do this. Okay, now I don't want to do this. If you want to do this, feel free to do it. I'm gonna continue to use star. Okay, and but it would be different when you would see me using this in a script in a production environment. It would be different. I would call the function so I can trace. But here, if you don't agree, don't use it this way. Okay, models. So all these models are available. 2-3 more functions that you should know about. Similar to models, the metrics that we evaluate, you can access them using get metrics. By default, accuracy, AUC, recall, precision, F1, kappa, MCC, these are what we track. But there is a function called add metric and remove metric to add or remove any metric. Okay, so I'm not going to do that, but there's a function there. And again, if you come to here and just search for add metric, type full classification dot add underscore metric, you would find the documentation, right? You would find the documentation, and it is very intuitive, very easy. I think it would also work here if you type add. Yeah. So you can explore this at your own time. Okay, let's move forward. There are 2 more functions that are very important. One is called get config, and one is called set config. As the name says, get config is to get the configuration, set config is to set the configuration. For example, so most of the things here, when you just pass normalize true, transform true, all the true and false, right? Fix imbalance true, even you can fix the imbalance data here. You just pass it true or false, right? So everything is happening behind the scene. But if you want to access anything like that, you have this get config and set config to your rescue, right? And what I mean by that, just to prove my point. So let's say I want to access X train set, X transform train set, right? So get config X train. This is my train set, 748 rows with 16 columns, and you can see this is already one hot encoded, right? See, special CHMM 101010. Everything is broken down into 10. And if I want to access my X test, I can access my X test like this. If I want to access my seed, I can access my seed like this. You can see 1, 2, 3 is the seed. What else can I do? So let me see what else is accessible. Most of the things, 99.9% of the things are accessible to you. Some of these you would not frequent, like you wouldn't want to play the background configuration of PyCaret as if you don't understand it, right? Similar to any software, right? If you're not expert enough in Excel, you'll not just play with everything, okay? You can access the prep pipe, so the what do you call it? Pre-processing pipeline. So you can see this is your pre-processing pipeline, right? And I think you can visualize it as well. So if you call from sklearn config, now how do you import it? Let me just check. From sklearn import set config as sg. Can I do that? sg, and then I would say sg dot display. What was the code? I kind of forget. Set config display is equal to diagram. Yeah. So this is the code of sklearn, which kind of, instead of printing the text, print the diagram. So see, so previously, so just so that I avoid confusion, so previously it was set to, and by default it is set to this text. Okay, by default it's set to text. So when I call this, I get this. Again, what is this? This is a sklearn pipeline. You can access them through list or whatever, the way you would normally access. But in sklearn, if you set a config to display, to diagram, then when you call this, you get the diagram, right? Sometimes it's easier, and you can see it kind of pass-throughs because we haven't used any pre-processing options here, right? So let me give you an example. So if I were to do a bunch of things, normalize is equal to true, transformation is equal to true, remove multi-collinearity. I can never spell that. It's true. PCA, let me also do PCA, true. What else? What else? What else is there? Polynomial features is equal to true. Just doing a bunch of things, right? I don't know if they're relevant or not, but I'm just doing it just to make a point here. Okay, you can see all these are true, 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 true. And now if I run this, you see this, make nonlinear features, scaling and power transformations. And when you click on them, you see details. Okay, all right, going back to original point, I'm just removing all this. They're irrelevant. This the point I'm trying to make. And then, so now we have talked about get config, set config. So we are all set, and let's quickly go through now the modeling thing, right? First function, which is the kind of backbone of everything else, is this. Is thing working? Yeah, it's working. Is this create model? This is the function. If you call help over create model, there's a documentation, right? And you can read it. It does many things. You can read it. I'm not going to go into detail now, but one thing that I want to tell, if you want to train a logistic regression model, it takes create model LR. LR is logistic regression, right? And how do I pick it? From ID, LR. If I want to train decision tree, what should I type there? DT. Okay, so if you just type this, it would basically train the logistic regression model using default hyperparameters. Okay, it's the same algorithm that is available there in sklearn. It's the same algorithm. It would train it using 10-fold cross-validation, which was defined in setup. By default, that cross-validation was stratified cross-validation. Right? I'm not going to go into detail. And how many folds? By default, 10 folds. You can change all this, right? But the point is, and it would train it on train set only, which is this one, 748. Okay. And in the last release, I think scikit-learn has changed the default solver of logistic regression. And because of that, logistic regression is relatively slower now. That's why it took that many seconds. But the point here is it's a 10-fold cross-validation on 700 and whatever number of records in the training set. And it evaluated that 6 metrics that I have shown you with this function here. Get metrics, this is the same 6 metrics. If you want to add your own metric, let's say ZZZ, you can do that using add metric and remove metric, and remove it using remove metric. right? But this is the same thing. The last two lines is means and standard deviation. So now let's train DT, right? And now even without looking at this grid, if I ask you if LR is for logistic regression, DT is for decision tree, what is for random forest? It should be random forest, right? RF. This is random forest Stanford, right? And when you check these things, right? So I just print random forest. This is a random forest classifier. From type, it should be sklearn, right? Sklearn inside type LR. Oops, not this LR. Remark, right? Very simple. If you want, if you are smart enough, you can do something like this. Models all no. Select models is equal to LR DT XGBoost light DBM knife base, and then you would create something like this. For I in select models, create model I, right? And if you are more smarter, you would do something like this. Or select models is equal to list, right? So for I in for create model I, for I in, will it work? Yeah. So this is list comprehension. So basically I'm saying create model I for I in this list. So basically create all these models, right? Why I don't care about storing them, why I don't care about anything, the metrics and everything. Remember, the MLFlow is working, right? So I go to Juice22. Let me show you here. So previously I've only seen this setup thing, right? Here, session initialized. Now you can also see these models. So if you click on extreme gradient boosting, here's all the parameters of extreme gradient boosting, right? And this time you also have metrics. All the other details, that same holdout grid, that the result grid that you see on Jupyter Notebook, you also get it stored as a HTML file. And this is nothing but a file. So I want you to think you have systems, you have your own organizational systems. At the end of the day, this is a gold mine to you. This is gold mine because you are generating an embedded output that somebody in your organization, in some other system, they would hook into this location. In this case, this location is my computer, but in real life, in the work that I do in my office, we have set up this entire thing on S3. So somebody would hook into S3 and access this and just embed it in their system, right? Gold mine. This is gold mine. The actual model is here. The actual model is here too, right? This is the same scikit-learn object. It would give you input example. So if you are doing a JSON something to send queries, this is how it should look like when you send a query. It would generate a conda YAML file for you. So in case you want to take this thing and put it in 10 seconds on Kubernetes or any cloud engine, this is the conda YAML that you can use. The only dependency is PyCaret 2.2.2, the version that you have used yourself to create the model. And this is also metadata for production purposes. Okay, let's go back. Now in this case, select models is a list of logistic regression, decision tree, XGBoost, light GBM, and knife base, right? Because of this, right? Now if you're more smarter, you would do, I mean, instead of hard coding this, you would do something like this, right? Models, because remember, models give you this. Okay, models give you this. Now if you want index, because remember this is an index column, right? You want to call index out of it. You get index and then you convert it to list, right? So now basically this is the list, right? So basically instead of doing this hard coding thing, I'm not going to do that. It would take time because you'd be training 16 models, 10 folds cross validation. So 10 times 16 is 160, and then you're evaluating them for 6 different metrics. So that means 10 times 60 times, I don't know, 6, whatever that number is. Imagine just in this one line, you have generated 500 data points. And if you are not keeping track of it, MLFlow is doing track for it, right? So you can see this, everything is tracked. So in this grid view, if I just hide parameters, version, source, I don't care about user because I'm an individual user at this time. this is a functional table, right? This is not in black background. This is not beautiful. There are no pictures, but this is what you need in real life. You can sort this. You can look at your final model. You can come here. You can type notes, right? You can do something. So this is how we use it in production. Note 19/12/2020 model drift less than 2%. Continue for production run. Recheck in March 2021. AM, VM, MS. You sign initials. Save. Right now, your colleagues in different country, in different teams, when they open it, or normally the ML op team is separate, right? Like we are responsible for building model, prototyping, but then there is a counterpart somewhere sitting in IT. You don't have to like sit together to take this model in production, right? You do your thing, your team does your thing. You write notes, they come here, they see the notes, take the model to productions. It's a very processing, clerical, very operational thing. As cool as it may sound, this is operational, very operational in nature. Okay, moving forward. So for create model, for the function create model, very important function, we have this. Then we have a similar function called tune model. Create model uses default hyperparameters. So if I show you DT, let's create DT, and this time create DT with 5-fold, just to make a point. You see now there are 5 folds, okay? I'm not gonna do that. It's kind of pointless. DT, okay? And now what I wanna do is this is using default hyperparameters. Okay? If you see this is using, these are the default settings of decision tree in sklearn. Now there's a function called tune DT, which can take your DT as an input and tune the hyperparameters based on the optimized parameters. So by default, it would optimize accuracy. So let me change it to AUC, okay? Actually leave it. Remember, this data set is not unbalanced, right? So DT, and now this would in parallel use all the cores on your computer, would tune the DT. And if you see DT, previous AUC was 7420, and now it is 86, so 12% increase. Why? How? Just check DT. So this time you see max that by default is none. It's now 4. Why and how this is happening? There are grids. We have done a lot of research work, and we have set up grids in the background, grids that can generalize well over large amount of data points, over large amount of different data types, okay? So we have those grids. You're not limited to these grids. If you have your own thing, you can just pass the custom grid. Just pass the custom grid as a dictionary, normally like same way you would do with scikit-learn, right? But the thing is, if you don't want to, you can go with our default values too. They work generally well, but there would be cases where you would need to pass your specific parameters, right? But then again, remember, this is using random grid search. So we have grids set it up behind the scene. It would iterate over it number of times, and that number of times is decided by n iter. So by default, it is 10. It is possible that if I just increase n iter and nothing else, the model may improve further. So imagine, so this one is 8669. It didn't improve in this case, but the point I'm trying to make here is because it's random, there is chances that your model may not improve when you're tuning, or it may improve when you increase the number of iteration because it's random, right? And how is that randomization controlled? At a seed level that you set in the setup, okay? So now this is using random grid search from sklearn, but there are other methods as well. And those other methods, you would often hear people talking about Bayesian optimization, or using libraries like Tune sklearn or Scikit Optimize or Optuna or HyperOpt. Again, which works better? I don't know. Nobody knows. Different data sets, different problem, different methods, different approach. Just like there are 10 different methods to normalize your data, min, max, z-score, quantile, blah, blah, blah. Similarly, there are 10 different ways to hyperparameter tune your model, right? Or tune hyperparameters of your model. But the good news is, all of them, by the way, all those libraries have different interfaces. So if you have to work with Optuna, HyperOpt, you have to learn 10 different methods. Okay, if you want to use them, you have to learn their methods. Their APIs, their interfaces are different. PyCaret took time to combine everything. So now, if you want to use Optuna instead of scikit-learn grid search, and Optuna has its own maths, it has its own theory, has its own method. Good or bad, I don't know. But the good news is you can just pass a search library parameter, Optuna, and no change for you, hands down. It's working this exact same way as anything else would have worked. And in this case, we are lucky. If you see, we got 87 for 1. Optuna increased it further. But it is so naive of me to just say that, right? Because it's not a valid comparison. What I should be doing is comparing scikit-learn like this with time. And again, this is not a good method because this is just doing it once, right? But just to make a point, the way I would read these two things is and this time it screwed up, right? 8373. It didn't work well.
Hello, Moez. Hello.
And you need a high quality.
Hello, Moez. I think we lost you for a while. Hello. Hello, Moez.
You're comparing
For a while. Hello. Moez, we lost you for a while. Hello. Hello. Yeah, we lost you for a while. I think there is some internet issue or something, maybe at your end or not sure. Hello, Moez.
Can you
Hi.
hear me now?
Yeah, we can hear you now. Yeah, yeah.
Sorry, man.
We
No,
lost
no.
you for a while. Yeah, no problem. Yeah. Hello. Hello. Hello, Moez. Yeah.
Can you hear me? Sorry, man. I think my internet is giving me trouble.
Yeah, there was some issue with the internet. Yeah, now it is audible. Yeah. Now also the bandwidth is good. Yeah, it's perfect.
Okay, let me share my screen. I'll
Yeah.
I'll 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 switch off my camera just so that everything is okay.
Yeah, sure. Works. I think we
Okay.
lost you some 10 minutes ago or so. I think it's around yeah.
What was the last thing you hear?
Let me just tell you. I think it's about I think you were talking about the decision tree classifier, tune underscore DT. Yeah, that's where we lost you. Yeah.
Okay, did you hear me talking about all the different methods of hyperparameter tuning or no?
Yeah, I
It
guess.
just started
Yes.
covering that. Probably
Yeah.
we can go through the hyperparameter tuning part quickly.
Yeah.
Okay, sure. Sure. Let me go back to notebook.
Yeah. I think it's near decision tree tuning. I mean, that's where
Okay.
TUNIT. Yeah.
Okay, so let's go back. So we have talked about the hyperparameter tuning. Okay, so this for example, you just pass your decision tree. Can you hear me?
Yes, we can hear you. Yeah.
Perfect. So
Yeah.
you have trained a decision tree using PyCaret model. Okay, and it uses default hyperparameters. So what I mean by that, if I run just DT again and show you the hyperparameters of DT, it would use the default values, right? Whatever the default values in scikit-learn is, right? And they can change over time, or they have changed in past as well. Um, but when you use create model DT, it uses the default hyperparameters, and this is training. Let's give it a second here. Mm-hmm. Okay, so if you see the default hyperparameter, so the accuracy is, sorry, AUC is 7420, and this is your default hyperparameter, right? If you just print your DT, you would get this. Now there's a function called tune model, which takes your train model and tunes the hyperparameter. By default, it will use a random grid search from sklearn, right? So if I just learn tune model DT, it would basically, let's say result first. So now my AUC is 86%, average accuracy over 10-fold is from 74%, it goes to 86%. And the reason it goes to 86% is we have iterated over various combination of hyperparameters that we have decided behind the scene. And if you just print it, you would see that max step now is 4, max features log 2, impurity decrease is 0.002, which is 0 here by default, right? So basically, we iterate over various combinations of hyperparameters. Now, if you want to define your own, you can just pass custom grid here as a dictionary, like you would pass in scikit-learn. But for most part, our default parameters would work or generalizes well over a variety of data. Now, this is one method to tune hyperparameters, right? Scikit-learn random grid search. Okay, but then there are other libraries, other methods like Optuna, Scikit Optimize, Bayesian grid search, HyperOpt, blah blah blah. Right? There are 5, 10 other libraries that also does that job. The methods are different, maths is a little bit different, technique is different, or the methods are different on how you would iterate over a search space and find the optimal parameter. If you want to use those libraries, you would have to learn 10 different APIs, 10 different interfaces. All of them work differently. What we have done here in PyCaret is we have combined them. So you just use a search library parameter inside tune model to kind of use other libraries. So for example, instead of if I pass this tune model DT search library Optuna, the model is same. The tune DT is still decision tree with the tuned hyperparameter from whatever the parameters are there in scikit-learn. But now if you see, this has 8745 AUC, right? This one took 4.19 seconds to come to a point where we have 86.6% AUC. This one took 399 to get to a point where we have 8745 in AUC, right? Then there is tune sklearn, there is scikit optimize, there are other methods. The point here is convenience. Instead of you using or interfacing directly with those libraries, if you use them here, you have a same API or a consistent API, whether you're doing classification or regression, right? And then I encourage you to check the other parameters. So once you select your search library, so let's say you select tune sklearn, you have more options to pass in terms of search algorithms. So if you pass tune sklearn as your search library, you can use Bayesian grid search, you can use HyperOpt, you can use HP Benzer Bob, you can use grid, random, right? So explore it at your own time. Similar to tune, there is a, can you hear me? All okay now?
Yeah, it's perfect. Yeah,
perfect. Okay. Similar to tuning, there is a function called ensemble, which basically ensembles the model. So I create a decision tree here, put it inside ensemble, and the output you get is nothing but a bagging classifier, which is wrapping a decision tree that we created, right? Now, if you want, you can do, instead of passing DT, I would have passed my tune DT, right? That makes more sense. So now the same bagging classifier that wraps a decision tree, if you see my screen. But now if you see this 0.02 min impurity, this is coming from the tune model, right? So imagine, so I took my decision tree, my base decision tree gave me how much? 74 something in AUC. Where is my DT? 74% in AUC. Then I tried couple methods to improve my AUC for decision tree. I ended up with this Optuna grid search, which gave me 87.45, and then I ensembled it under a bagging classifier, and eventually my final AUC, you see here, it was 88.30. Okay, so this is like a workflow you can build. Okay, now there's another function in PyCaret called plot model, which kind of analyzes the performance of your trained model. So if you just pass plot model DT, it would give you AUC. AUC is a default plot, but there are other plots that you can do. Plot is equal to confusion matrix. It will give you confusion matrix. Plot is equal to, and imagine the power of this is the way you want to use it is like this, right? You would say DT and confusion matrix and tune DT confusion matrix, and then you can compare. Okay, after tuning, you can see my true positives increased by 20 or something from 86 to 104. True negatives also increased, but these two here, 46, 40. This is problem, right? Have I improved? Yeah, 26, 30. I improved. Does recall matter more than precision to me or not? Right? So in that case, I mean, you can do that quick comparison, right? And even something like this, right? You would say, give me the boundary of DT and give me the boundary of tune DT, right? Am I overfitting after doing my hyperparameter tuning? Am I overfitting? I mean, obviously this is PCA. There is a loss of compression, loss of information there, but you can take it. I mean, 85% of the semantic information is retained, right? But things like this. And if you're too lazy to use plot model directly, there's a function called evaluate model. It would only work on Jupyter Notebook because it has these buttons or widgets, which would not work on your command prompt, right? But essentially what it does, it gives you a list of options that you can choose from. So in this case, hyperparameters, AUC, confusion metrics, precision recall, classification report, prediction error, learning curve. What else? We have seen decision boundary, lift chart, gain chart, gain, lift. This calibration curve, another important concept maybe for some other day. And then if you're passing decision tree, I think, plot model decision tree, and then you can also plot tree. So this would basically give you a decision tree, hopefully. Yeah, it's loading. Okay, what else? So we have talked about create model, tune model, ensemble model, plot model, and the best way to learn all about this is this: you go into module, just read it like a English newsletter, right? Just read this thing, and you would get it. It's very intuitive. And remember, whatever we are doing behind the scene, here is our server running, right? And this is at the moment on my computer, but in real life, you're working in a team of 100 data scientists in 50 different countries or whatever, right? And you would have usernames here. So the person who built the model, the person who pushed the model, the notes, everything, the entire governance process is happening behind the scene. I'm going to stop this because I think the decision tree would take some time. Oh, there you go. Right. I'm not going to rerun or take the risk to rerun this, but this is not readable. But what you would do in when you're using it, pass the scale to 5. So it increases the size, and then just pass safe is equal to true, because it is more convenient to read this in a JPEG file instead of reading it here in the notebook, right? Anyways, moving forward, in real life, I mean, I showed you all these functions because these are building blocks, okay? But you are more likely to use PyCaret in a way that you would set up and you would compare. You would use this function here. That's compare models, okay? And this functions also take a lot of parameters, right? But if you can just run it like this, what it would do behind the scene, it's a loop. Under the hood, this is also using create model, but it's a loop. It would iterate over all the models that is there in the library, right? Models is the function that we have used to see that, right? If you remember the table that shows all the models, which is this, okay? And it would basically iterate over the loop and give you the average performance fold. So the yellow highlighted mean line. So all these numbers are mean. So you can match it. This 83, 20, 28 is the yellow highlighted LR number. So if I go back up to my LR model, I created LR anywhere. This one, 83, 28, 89, 33. So this line here, when you use compare models, only this. Obviously, I mean, you want to compare the models, right? The orders of the models between models. Okay, so this is what you get. And this is how you actually start your modeling, right? This view is I select, so it would automatically model. Instead of returning one model, you can also pass n select is equal to 3. So it would return you the top 3 candidates. If I do this, is the best instead of a model in the interest of time, but this is what you can do. So this is how you use, okay? Now, I'm gonna show you one thing quickly, and then we'll move into deployment right away. I think we are running way over time, and then we should wrap this up quickly and leave some room for Q&A at the end. But overall, this is the structure, okay? So now let's jump into a second demo where we would build a regression model and cover the deployment part there. And all of this behind the scene is you know, storing in a server. And the good part is, I mean, you can download this entire logs in CSV as well if you want. There's a download CSV button. You can download CSV, and you know, no matter how useless you think Excel is, this would be the fastest tool for you to do pivot tables or things like that. I don't know what I did wrong, but it didn't download anything. But it's supposed to give you that list. But anyways, there is another function here which gives you logs. So if you just type get logs, you would get a pandas data frame here as well. So this is the one. And then what you can do is to CSV and just write it. Right. So it would basically write a haha.csv here, which is your which should be a so this is the file. So all the run IDs and all the metrics, right? All the metrics are here, parameters are here, and then model names somewhere towards the end should be here. Anyways, you'll find it some here. This is the one. All these things, right? Okay. Moving forward. So what's the point? So the point is you're using PyCaret and you are iterating over these things very quickly. That's the point. You're saving time. You're iterating quickly. Now you have finalized, after all the exercise, you have finalized one model, right? You have finalized one model that you want to push into production. So I'll show you that now. So let's pick a use case. Can you hear me okay? Just a confirmation.
Yes.
Okay, very good. So now I'm gonna close a couple of things in my computer because things are getting slow here. I'll close this. I'll close the website. Give me 2 minutes, guys. So what is taking time? Google Chrome. Okay. All right. So I've opened a new notebook. And again, the data set I have, I think I have import pandas as PD, data is equal to pd.readcsv insurance.csv. I have this data set here, and I'll show you what the data sets look like. This is the data set, okay? Each row, it's a regression use case. Each row has attributes of patient age, sex, BMI, children, smoking status, region, and the charges they get when they get admitted in the hospital, right? It's a pretty small data set, but the use case is insurance company want to predict in advance what will be the charges of this patient in hospital when he or she gets admitted. And the reason they want to do it is so that they can appropriately manage the cash flow, okay? Okay, so this time around, I'm going to import everything from regression. I'm going to set up the exact same way. Data is equal to data, target is equal to charges. I'm going to pass in a seed that locks in. Okay. I think something is it's normally faster than this, but I think because of this live restream, it's taking a lot of memory on my computer and things are getting slower. But it's exact same thing, right? So I just confirmed all the data types by pressing enter, and this is all the thing I get. Now at this point, I can run compare models, okay, and let me do that. Best model compare models. And just so that you know, I'm gonna exclude GetBoost, Rensack, PR. What else? So let me first show you how many regression models we have. So all these regression models, okay? And now I'm passing a list of exclude IDs so that they doesn't get trained. I want to speed up the process. I'm blocking Huber. I'm blocking Bayesian Ridge. LR lasso is fast, OMP, blah, 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 blah. Okay, the reason I know that these models are relatively slow because I have worked a lot with these models, right? As soon as I run it. So now what would happen is it would train all the models in the library, excluding these models, okay? In past, this parameter was named as blacklist and whitelist, but 3-4 months ago, we have renamed all the blacklist and those kind of parameters to exclude and whitelist parameters to include. Okay, so this is gonna take time. I'm gonna shut down the MLFlow server as well. And again, in case of regression, instead of accuracy AUC, you see MAE, MSE, RMSE, right? But again, you can use your own metrics, customize metrics. Obviously, sklearn has like 20-30 metrics we are using here only. You can add them very conveniently with just one word. But if you want to design your own custom something really different, also do that. Again, I'm not going to talk about those now, but again, you can read documentation. It's crystal clear on how to do that. And I promise you, it will not get easier than that anywhere. Okay. Okay, so let's keep this short. So the best model ends up being GBR, gradient boosting regressor, right? And the way the way you can use it, so this R square 8348 is on the train set, right? It's a cross validation, average 10-fold cross validation on these rows. Now you want to check the holdout set, and holdout 402 records. We haven't used it, right? It was transformed. It was split it in the beginning, right? And then it was never touched. It was locked, okay? But now what you can do before getting this thing into production, let's say GBR is your final model, and I'm skipping all the tuning, blending, everything here, right? Just in the interest of time, I'm skipping that. But you know how to do it, okay? If you have to do it, you know how to do it. The one last thing you should also check before taking this into production, this is the cross validation, right? But you want to also check the score of this model on the holdout. And the way you would do that is you can simply call a function called predict model and just pass in your model. In this case, my model is stored in best model, right? And when you do that, you get a grid which gives you a score on a holdout set. So this mean absolute error, $2,702 is on training set, and it's a 10-fold average. And on test set, my mean absolute error is 2386. Seems like it improved, but again, I mean, I wouldn't go into theory of overfitting, underfitting, blah, blah, blah. But the point being, this is how you can use this function to do that. Now, if you want to generate predictions on new data set, then simply pass the data. And when you do that, what you get here is a data frame, untransformed data frame. Behind the scene, we would do all the transformation, but untransformed data frame with your label prediction column. So in this case, I mean, you also see the charges column because I haven't dropped it, but nothing to worry because we will ignore it. We will not use it in any way. The only thing we will use is this 6 columns because they were used for training. Now, if you would have passed feature selection or feature interaction is equal to true, we would have used those newly created features when training the model, and we would also use them when we are doing the inference, but you won't see those things. I mean, if you want, you can access, but at the end of the day, you and your users, your business is interested in this, and that's what you get, okay? So now this is one way you do it in Notebook. Now, the point is in real life, you don't have, the new data is not coming in through CSV files, and in some cases it may, and we have processes where we are doing outside of context ETL using Alteryx and some desktop tools and doing that. using UI path, but more likely you would take this model and predict and put it on as an endpoint somewhere, right? And now there are a couple of ways to do that. One, the first thing you should know is you can save the model using save model, and you can load the model using load model function, right? And you can check the help of this, right? This is the help. And what I'm going to do now is I'm going to save this model, best model, right? And name it Moez, right? And you can see if I go into my folder, I would see Moez here. Okay, but I don't need to do that. Now, if I want, I can just load this back. Let me just show you as a proof. L is equal to load model, just pass Moez. And now if I check L, this is the model. Now you can use basically predict model on L, and it would give you prediction. Okay, this is the same thing that we have seen before. The difference is this is now not just the model, but the entire pipeline. So everything that happens in middle, imputation, one-hot encoding, feature interactions, polynomial features, dropping irrelevant features, categorizing them, binning them, it would automatically orchestrate them. But normally you wouldn't want to save it on your local, right? What you want to do is take this thing, right? First thing, you can save it on your model local, right? So I can save it, save model, batch model as a final model, and save it. And I can see I have this final model here, right? Date created 156. I don't know, this is old. This old? Yeah. So where did the new model go? Here it is. 1152, which is right now. Okay. Okay, but so this is I've saved in locally, but what you can do is you can also use this function called deploy model and push this model directly on cloud from this environment, right? And this is how we do it. So I'll take batch model, right, and name it. Let's name it okay. Platform is equal to AWS, and authentication. For AWS, it's different for everybody. For AWS, it only needs the name of the bucket, right? For Azure, it could be different. GCP is different, but this is AWS. And it would take some time. Okay, so this is now deployed entire pipeline to AWS. And now if I go and show you my AWS account, hopefully I remember the password and everything. Okay, auto login. I go to S3. Okay. Under my S3, I would see this test bucket, right? This is same as this guy here. And then when I click on it, I should see here. This one, okay? And then you can, and on some other computer, on some other hardware, what you would do is from PyCaret. Now this is production. So you would do this from PyCaret regression, import load model and predict model. L is equal to load model, and you wanna import platform is equal to AWS. Authentication is equal to, let me just copy it, and then predictions is equal to predict model. L, let me save it, not L, imported and then you take imported and pass it in here, and then pass data to data. So now this script here, this is your production script. What this is doing is loading the model from AWS bucket, whatever the bucket is. And remember, I mean, see that there's no risk here, no password, no authentication tokens are in the notebook. Everything happens in command line. You have to set it up once, and then it is generating these predictions and storing this in data frame. I should have called it off. So this is the same thing, 18250, 18250. This is exact same thing. With the difference this time, the model wasn't sitting on my computer. I got it from AWS. Okay. All right. Now let's quickly move to the front end thing. It's not a big deal. I mean, I know most people think deployment as like something really cool or something out of the world, but it's very basic. There are a couple of frameworks that you can use to now. So imagine in this case, what is happening is we are loading the model or pipeline in Pandas in Python, and then passing the batch of data. So multiple data points, right? 1300 data points. We are passing a batch of data and generating prediction. Now, there are both cases, right? In real life, you have situations where you want to do the batch prediction. Let's say you have a job running once in a week that runs on a customer data set, and you predict the churn. And on Monday morning, all your business need is a table output which says the highest probability, so they can call the customer, do cross offerings, and retain the customer, right? This is also possible, and sometimes you need a system which is live, right? Your customer comes in and say, I'm buying this. For example, Tim Hortons, right? You're buying this. On the fly, they would project you on their monitor that what else should you buy, right? I mean, this has already started in 200 locations. Pilot has been done. Very soon in Tim Hortons on monitors, you would see that. If you are based in North America, sorry, I forgot that context. Okay, so for the second part where we need an endpoint, there are a couple of frameworks that allow you to do that. Flask being one of them, Streamlit being one of them. And let me show you Streamlit first, right? Streamlit is a very Pythonic application. And what I have here is this app.py file, okay? And what this is doing is same thing. This is what I've shown you. PyCaret.regression, load model, predict model. This is importing Streamlit, pandas, numpy. This is the load model function of PyCaret that I've shown you. This is loading the file, right? In this case, because I didn't have this platform is equal to AWS, authentication is equal to blah, blah, blah. It would work because the final model, the same file is also in my local location, right? I just done. You can actually pick it from AWS, Azure, or whatever. And by the way, if you check the documentation of this, help deploy model, it is very detailed. It would show you basically if you are using GCP, this is what you should do. If you are using Azure, this is what you should do. If you're using AWS, this is what you should do. Just now we have used AWS, but using GCP and Azure is not different. Instead of passing AWS, you would pass Azure, right? But the setup of those are a little bit different, but nothing that you cannot do. Okay, I have a predict function here that, again, same thing. It is calling the same predict function that you have seen in PyCaret, right? And then it is slicing. The reason it is slicing now, because imagine this is the app that you want to input in a form and get one by one prediction out, right? Like a front end. And I'll show you in a moment what it means. So this is a predict function. This is showing an image, and I'll show you the application. It looks a little bit relatively presentable, right? And then all this is doing is taking the value from you. This is a Streamlit. So if you have used a Streamlit, this is giving you an input box for age, select box for sex. So this is like designing your Microsoft forms, okay? And the only important thing here is this. If the button is clicked, if st.button, if the button is clicked, take the model that we have just loaded here, model, and take the data which we have just created here, input df, which is this, right? One by one, remember, one by one. And then when you click it, just give the prediction out. It's the exact same thing that you would do in Jupyter Notebook, but now that you have front end. So the way you would run a Streamlit app is by going to command line and then navigating to the place where your files are, right? And I have the app here, and then Streamlit run app.py. Nothing different there, nothing unique. This is just the way you would run the app, okay? Just like you would run Python with Python app.py or whatever the file name is. So this would again initiate a server on your local host with a port 8501. We're different here. And this has in a very short time, I was able to build this front end, and I think it does the job, right? It's working, it does the job. This is the image that we have seen in the visual code, hospital.jpg. This is the image logo here, PyCaret's logo, and this is the form section here. Age, sex, BMI, children, smoker. This is the form section here that you see here. What this allows you to do is change the age, right? Or do whatever. Instead of input box, I decided to have this plus minus thing. Select the gender, children, smoker status, and then when you click on predict, the script should work and bring back to you the prediction, $14,400. This is same as if you were to call the these data points here in Jupyter, and let's try that, right? So 19 and female. 19 and female. 27.90 yes. Okay, so the output would be a little bit different because this form doesn't allow for decimals. I didn't realize BMI could be in decimals. So children, a smoker yes and southwest. So smoker yes and southwest. Now if I get predict, I should get a number closer to this one, 18, 20, 50. Yeah, 17,587. I think this is happening because of this 0.9, right? Let me just increase it to 0.8. Is there children here? No children. Yes, southwest. Okay, 18 to 50. This is what we get here, right? So it's the same thing. It's the same thing. Again, if I show you Flask, it's again the same thing. It's doing its exact same thing. Loading in PyCaret, loading the model. Flask work a little bit differently. I mean, it's a broader framework. But let's just run Flask as well, right? So I'm in the same folder to run Flask. I would say Python app 2.py. And this time when it would also initiate a server, a development server on my computer. Might take a little bit of time, but it's the same thing. And again, if you're looking for sample code, it is uploaded on GitHub first of all, and then if you go on my Medium, you would find a lot of articles that explains this relatively in more detail. And also the last step after this application, instead of running this on localhost on my computer, what you want to do is push it on cloud, right? So if you go on my Medium, you would find a lot of articles for each category. You would find how to do this on GCP, how to do this on AWS, how to do this on Azure. And I recommend you go there, and at the end, the last part of my article basically shows the step-by-step. Open aws.com, click here, left click here, right click here. And I'll show you the part that you should be able to follow very quickly. Okay, let's open the Flask app, which is now on my 1234 port. And it would open an app with a good background, relatively better, because there is theme there's HTML, and I don't know any of it. So I basically went online, picked one of the open source CSS template and just use it, right? You don't need to know HTML in order to do that. I mean, you can rely on other sources, other people to do that. But the concept is the same form, everything same. If you click on predict, it would throw a number back, which is this number. And this number is exact same as if I were to go here and pick these characteristics: 19 female 27.9, 19 female 27.9, 0 yes, 0 yes, southwest, 18 to 50, right? Perfect. And now the last thing I want to show you is if you were able to understand 70% or 80% of what I said today, you should be able to go on Medium, right? Let it open for a while, and then I don't know, man. This live studio is killing my computer, man. Everything is slow. Something's going on, but anyways, I think I'll leave it to you guys. You go on Medium, my profile, go to articles. It's a 10-minute article, and if you think it's important, I think it's worth investing time for you guys to read that. So I'll leave it to you, and we'll just end the session here and open up quickly for maybe if there are a few questions that we can take in the next 4-5 minutes.
Yeah. Gunika,
Yeah, we do have some questions. So the first set of questions is basically, how is PyCaret different from other AutoML tools like H2O Flow, K9, and is it similar to MLFlow? Yeah.
Okay, so the way it is different than other, I would say other libraries is, first of all, it's not AutoML. So PyCaret, you can have both experience. If you're doing in-person modeling, sitting in front of computer, doing create model, tune model, ensemble model, you can do that. But you can also schedule these scripts, right? You can schedule the workflows. So it may run in an automated mode if you want, but more normally it's created more for as a common interface for multiple libraries. So this is very different than just passing your data frame into H2O, first of all, right? So in that sense. Second sense, I think the second question was, is it different than MLflow? Yeah, MLflow is one component of PyCaret. MLflow is a logging interface, right? So similar to TensorBoard for TensorFlow, it's a similar concept. And the third or majority of the biggest thing I would say is the functionality and features in PyCaret. I may be a little bit biased there, like we are the developers, so I'm biased, but the functionality in PyCaret is extremely broad compared to other frameworks.
Okay, got it. And does it support time series like LSTM and GRU?
So LSTM is neural network, right? So we are not doing anything related to deep learning. We prefer, if you are doing deep learning, if you prefer deep learning, if you have business problem in hand that is more appropriate for deep learning, I think TensorFlow there, PyTorch has done already a great job in kind of creating that that layer of easiness, especially with TensorFlow 2. Although there are a few things that we would like to kind of compress with our integration road in future, but it wouldn't be something. It wouldn't be a very different thing, right? So I think at this point you're better off using LSTM directly from TensorFlow. I don't see any value of us just creating a wrapper over it. For time series, you can treat your time series problem into regression, right? And remember, I showed you shuffle parameters in the setup and the k-fold, k-fold, stratified k-fold, the fold strategy parameter. You can set that to time series. If you read the documentation, there's an option of time series. What it does is, instead of doing random k-fold stratification or splits, it would do a rolling split for time series, right? So you can do that. You can frame your problem into a regression and solve it. But the good news is there is a new time series module coming in, which would be very broader than just doing simple ARIMA. So it would have a lot of functionality. So there is a very specific dedicated module for time series coming in future.
Great. Also, if there was a class imbalance, would we use Smote first and then proceed with PyCaret?
No. So the reason you won't see fixed imbalance or class imbalance very popularly in frameworks is because developing that functionality is harder, right? Because your entire framework is based on train text split. When you talk about class imbalance and you have a cross validation, sorry, your entire framework is on cross validation. But when you start talking about class imbalance, you will have to make a lot of technical changes under the hood to allow that. Because if we apply class imbalance or Smote or any technique like that on train sat, your cross validation results would be misleading, right? Because then you're cheating. So when you fix imbalance, fix is equal to imbalance true in PyCaret in setup, what we do is we create synthetic classes in cross validation, not outside of cross validation. So for every cross validation, we do it in the cross validation. So you can't access that Smote class outside, but just to ensure that the cross validation results you are getting is reliable, we apply that within cross validation, and it is one of the hardest thing to do from technical perspective. So you don't need to, short answer, you don't need to fix it yourself, because if you do that and pass that data to PyCaret, I mean, you would be misleading, right? So the best option is pass fix underscore imbalance is equal to true.
Yeah, great. And can we work with it in Google Colab?
Oh yeah, 100%. You can work in Colab, you can work in Kaggle kernel notebooks, you can work with Azure notebooks, you could work with SageMaker AWS, you can work it in with Alteryx or any environment. So we have put extraordinary efforts and focus to ensure that You have PyCaret accessible into all environments that analysts normally use. We have gone to a point where we had, had at one point had a discussion to create an Excel add-in for PyCaret.
Wow, that's great. Yeah. The difference between PyCaret and Flask. Why should anyone prefer PyCaret instead?
PyCaret over what?
Flask.
Flask.
Yeah.
Well, Flask is a web development framework, right? I mean, there is no like it's
No
easy.
comparison as such.
There is no comparison, right? It's not in the
Yeah.
same category.
Yeah. Yeah. Just wanted to put it out there.
Yeah.
Okay. So also is MLflow a part of PyCaret or does it need to be separately installed in Collab or elsewhere?
MLflow is a part of the mandatory dependency of PyCaret. So when you pip install PyCaret, you get MLflow with it.
Got it. And where are we storing these AWS settings? Like how is the code connected to the S3 bucket?
That's a good question. So if you read the documentation for deploy model, I think you can still see my screen, right?
No. Chanakya, can you please change the settings?
Okay, I think that's okay. So if you check,
we can see the screen now. Yeah.
Okay. So if you check the documentation of deploy model, it would basically tell you how to do it. So let me read the 4 lines for you, right? Because what I really want to stress here is don't run away from documentation. I mean, this is really different. Our focus was like make documentations in English, okay? But for human beings. So let me read this. To deploy a model on AWS S3, environment variables must be set in your local environment. To configure AWS environment variables, type AWS configure in the command line. Following information from the IAM portal of Amazon account is required. So what it means is I need command line. I need to go to command line and type AS configure. The moment I type that, it would give you some kind of error, but then it would start asking you for access key. I'm going to close this. Obviously, I don't want you to see my access key, but it would ask you for these variables that you need to type. Where do you get these variables? Go to your account, go to your profile, and go to your security credentials. I'm not going to click here, but go here. You will find those. Similarly, for AWS or for Azure, for GCP, you read the instruction GCP. To deploy a model on GCP, project must be created using command line or GCP console. Once the project is created, you must create a service account and download the service account key as a JSON file to set environment variable. More info. Now, in this case, this is a little bit complicated because GCP wants you to point to a JSON file instead of passing the configuration in command line. So, but once you read this, it shouldn't be hard. Okay.
Yeah, that is clear. Also, there's a generic question like AWS, Azure, and GCP. Which one of these 3 is most used in industry, and which one should a beginner start learning first?
So it depends. I think in terms of market share, I think AWS has so if you just Google market share of cloud, you would see AWS is the biggest in terms of number of market share. And then Azure, and then GCP, I believe. Now, I'm not biased towards any of the system. I've used all of these. I've taught a couple of them and in my work. So one thing you should know, like at the end of the day, you have to use whatever your employer is using, right? Whatever your company is using. So it is very unlikely that you would have, if you're just beginning it, you can't have an influence over this. If company has account or company is using AWS, no matter what, you have to learn AWS. Now, in my view, from the developer point of view, I found GCP the friendliest one. So if you are working with GCP, you get stuck, you can get online to GCP portal and they have freaking support there, right? Somebody would get online and would help you. And that somebody is not a telephone agent. That somebody is a developer. That developer would get online and help you step by step. Click here, click there, click that. If something happens like that, and for Microsoft, good luck with that, man. You cannot get in touch with people in Microsoft. It's impossible. So zero customer service. Now, AWS has a big market share. So if you're thinking from the perspective of employability, that if I do this, my chances of getting a job is higher because more people are using this, then you would make decision based on that, right? But again, be mindful that based on the regions, based on geographic, the market share of AWS and Azure and GCP is different. But in short, the answer is you have to learn whatever your employer is using. So that's number one. You always remember, be ready to learn these things. Number two, if you are thinking in terms of easiness, customer service, GCP the kind of jobs or the type of industry or the type of location you're targeting. Based on that, the answer may differ. So
Yeah, that was really insightful. Okay, is there a way to encrypt the data to keep it in cloud?
I don't know. I think this is a relevant question for me.
Okay, so we can take one last question. Is there any step-by-step tutorial for PyCaret?
A lot of them, at least 1,000 of them. But the best way, so the
Okay, I think Moise got dropped off due to some internet connectivity or something. I'm not sure.
So if you go to tutorials, you will find official tutorials, examples. People have submitted the examples, so you'll find notebooks, and then resources folder. You would find a lot of articles. So all these articles. So for example, let's pick one: build and deploy machine learning web app using PyCaret and Streamlit. So this is the article. This is everything that we covered today. I think it's a similar tutorial, and it's a gold content, man. I mean, it is the simplest content available out there on internet. If you want to get your model from your notebook to cloud service in 3 minutes, this is the simplest thing. And this has basic. So this is the thing I was talking about. So in this tutorial, the rest of things we have talked about it, but here, step one, sign up on heroku.com and click on create a new app, this button. Then name your app, then click on create app, then click on GitHub button. So this is basically like, think about companies teaching you Microsoft Excel in 1990s. Click here, click there, literally that kind of tutorial. So I think the only thing between you and these tutorials is your time to read them.
Yeah, we surely as well. Okay, thank you so much for the informative session. Your presentation skills kept us glued to the screen the whole time. And thank you so much for your time today. Any last words you want to say to the audience, or anything that you learn in the industry that you want to recommend?
Yeah, I think for people who are just starting in now, I would say one word of caution is don't get carried away with these new things coming in every day, and it is, it's getting harder to trust one single source. Every company, every industry, every problem, everybody's using data science differently. I've seen people using data science terminology for audits and visualization mostly. I've seen people doing data science work as big as what Google is doing, or as cool as what Tesla is doing. So there's a whole spectrum of it. So if you're just beginning in, or you are only 1 or 2 year down in this field, don't mix up things. There would be people, like, everybody would have opinions, including myself. At the end of the day, you don't have to listen to any of them. Okay, you have to decide for yourself. The harder you work, the more you know about things. And final word, I would say, there is absolutely no shortcut. There is no shortcut, my friend. There is no shortcut. If you don't get through drill now, if you don't go behind the scene, take curiosity, take interest in statistics, if you don't do it now, it's gonna come back 8 years later when you are manager somewhere. It would haunt you. You would have people in your team who would ask you questions that why we are doing this, is it not breaching this assumption, that assumption, and you would be embarrassed at that time. So don't, even if you identify shortcuts, if you have a magic stick, don't take shortcuts. That's it.
Yeah, agreed. Thank you. And just for the disclaimer, in this session, we explored a very helpful and customizable option like PyCaret. Tomorrow, we have another session on Model Deployment 101 that will take you through the basics of model deployment and teach you how models can be deployed using Flask and Heroku as well. So thank you everyone for joining, and special thanks to the speaker. We can end the session now.
Thank you, everyone. Bye.